So we're going to be looking through the Transformers library today, going off on the lead that we got from our cohort friend, Khan. Thank you, Khan. We're going to be performing a review sentiment analysis on reviews soon, and I've been told to look at the Transformers library. So here I am in the Transformers library, and as we just found out, the Transformers library homepage kind of lands you here, and it explains that Transformers provides a general purpose architectures like models like BERT, GPT-2, XLM, Distill BERT, XLNet for natural language understanding and natural language generation, with over 32 pre-trained models in 100 plus language and deep interoperability. It's very interesting, and right here they say that you can choose the right framework for every part of a model's lifetime and train state-of-the-art models in 3 lines of code. This is one of the things that drew me to look into Transformers library, and it's one of the things that we will be trying to do today. So have a good time. We're going to be exploring the Transformers library today. Let's go to quick tour. So the library downloads pre-trained models for language understanding tasks, such as analyzing the sentiment of a text, and natural language generation, such as completing a prompt with new text or translating in another language. First, we'll see how to easily leverage the pipeline API to quickly use those pre-trained models at inference. Then we will dig a little bit more and see how the library gives you access to those models and helps you pre-process your data. Okay, I've got a clear image. Hi everyone. So from the very first thing you can do with Transformers, you can already get an out of the box task like sentiment analysis, text generation, summarization, question answering. This will be really fun to play around with. I'm really interested to see where we can go with this. There's lots of things we could do, and I've been getting some ideas, so stick around, we'll go through some of those ideas today. Let's see how this works for sentiment analysis. So here, from Transformers, import pipeline, classify equals pipeline, sentiment analysis. And then in the third line of code, they've managed to identify the sentiment of text. Wow, 3 lines of code. When typing this command for the first time, a pre-trained model and its tokenizer are downloaded and cached. We will look at both later on, but as an introduction, the tokenizer's job is to pre-process the text for the model, which is then responsible for making predictions. The pipeline groups all of that together and post-process the prediction to make them readable. For instance, classifier, we are very happy to show you the Transformers library. Label positive, score 0.999. You can use it on a list of sentences which will be processed and fed to the model as a batch, returning a list of dictionaries like this one. By default, the model downloaded for this pipeline is called Distilbert Base Uncased Fine-Tuned SST2 English. We can look at the model page to get more information about it. It uses the Distilbert architecture and has been fine-tuned on a dataset called SST2 for the sentiment analysis task. So let's have a look at the SST2. Stanford Sentiment Tree Bank. And why did I end up on... Here we are. The Stanford Sentiment Tree Bank contains 215,154 phrases with fine-grained sentiment labels in the past trees of 11,855 sentence in movie reviews. Models are evaluated either on fine-grained five-way or binary classification based on accuracy. And the binary classification, SST2, has 54,000 examples. So distilling refers to taking complicated information or more complex information and filtering and passing it into a simpler model, simple neural network. It seems like. Could be wrong. It's a good page to have up. And if we wanted to use another model in the Transformers library, for example one that's been trained on French data, search through the model hub that gathers models pre-trained on a lot of data, but also community models. And applying the tags French and text classification gives back a suggestion. The NLP town / BERT based multilingual uncased sentiment. So let's see how we can use that. You can directly pass the name of the model to use to pipeline. Classifier equals pipeline. Sentiment analysis. Model equals NLP town / BERT based multilingual uncased sentiment. This classifier can now deal with text in English, French, but also Dutch, German, Italian, and Spanish. You can also replace that name by a local folder where you have saved a pre-trained model, see below. You can also pass a model object and its associated tokenizer. We will need two classes for this. The first is AutoTokenizer, which we will use to download the tokenizer associated to the model we picked and instantiate it. The second is AutoModel for sequence classification, or TF-AutoModel for sequence classification if you are using TensorFlow, which we will use to download the model itself. Note that if we were using the library on another task, the class of the model would change. The task summary tutorial summarizes which class is used for which task. Not really understood in this very well, but let's go with it. And you can see that they've got a little switch button between the two types of code. So if you're using TensorFlow and if you're using PyTorch. So here we're passing a model object and its associated tokenizer. And we'll need the classes AutoTokenizer and AutoModel for sequence classification. There they are, and from Transformers import them. Now, to download the models and tokenizer we found previously, we just have to use the from pre-trained method. Feel free to replace model name by any model from the model hub. Model name, give the model name. Model equals one of the classes above, the auto model for sequence classification. From dot, and then you call a method from pre-trained and you pass it in the model name. Okay. Tokenizer, AutoTokenizer, call the method from pre-trained, pass it in the model name. Classifier equals pipeline, Model equals model, tokenizer equals tokenizer. So actually, this is only necessary if you want a tokenizer, is that right? That's really cool. So for anyone watching who's just learning or picking up machine learning, it's now easier than ever. This is really only if you want to tokenize the words that you're using in your data in a particular way. But you can just use, straight out of the box, 3 lines of code, a sentiment analysis classifier. So we're going to be doing that fairly soon. I do need to get a data set just to check how it's going to work. And I want to scrape some reviews from out there. The internet. So I want to scrape some reviews, but I know that might take some time to get set up again. So what I may do is I may have a look into that, but I also may just get a data set. But you know, we'll see how I feel in a second. So then we could use that data set to check how this performs, how it performs. You can share your fine-tuned model on the hub with the community using a method they provided. So if you don't find a model that's been trained on some data similar to yours, you'll need to fine-tune a pre-trained model on your data, and you can do that. Example scripts are here. Tutorial for uploading that and sharing it with the community is there. So now let's see what happens beneath the hood when using those pipelines. So as we saw, the model and tokenizer are created from using the from pre-train method. Using the tokenizer, we mentioned the tokenizer is responsible for the pre-processing of your texts. So first it will split a given text in words, or part of words, punctuation, symbols, etc., usually called tokens. And then there are multiple rules that can govern that process, and you can learn about them in this summary, which is why we need to instantiate the tokenizer using the name of the model to make sure we use the same rules as when the model was pre-trained. Yeah, Ginger Tonic, we can actually train this model, and we can actually use this model, pre-trained model, in 3 lines of code to provide us some sentiment analysis. Here's an example of it being used up here. In 3 lines of code, you import the pipeline, you create the variable, you create your classifier using the pipeline, it's a wrapper around all other available pipelines, instantiated in the other pipeline representation. The pipeline is simply made of a tokenizer and a model and some optional post-processing. It's essentially a way in which you can do what other libraries do, but just condensed down into a few lines of code. And then you can instantly get a response if you pass in some text or a list of texts. So you can give it a list of reviews, and each will provide a dictionary entry with a label, positive or negative, and a score, 0 to 1. The score, I suppose, is how far along into the negative or positive regions it is. And so 0.9 is very positive, and 0.1 would be very negative, I guess. These are all very, official and well-known models that they're using. So, and you can fine-tune these pre-trained models to data that you have in the case that you need to, and that's really good. And they're also these pipelines are also you're able to not use the pipeline, and you'd have to add in a couple more lines of code, but then you get the access to all the tokenizers that you'd want, specific tokenizers and models that you can use, and they work well together to pre-process the data and get the data in a way that you need it. So yeah, it's really, really good shout from Khan. Thank you, Khan, again. Really happy with that. Okay, in the last few minutes of this session, we're going to go for a Pomodoro break. I suppose we'll just relax our brains for a bit and set up what we're going to do for the next time, I guess. There's a bit more to read. Okay, there's a bit more to read about. If we wanted to read a bit more about using the model, using the tokenizer, and accessing the code, we can. But then after that, it's pretty much installation and glance over the philosophy, I suppose, and then apply what we know. We can use the using transformers guides here to check it out. We'll need to access a data set as well, so let's fill these in. Alright, okay, let's make a page. Let's make a page, turn it into a page. Let's make a page and call this Transformer Library 101. Empty. Library. Great. And I suppose we should certainly link to here. Link to library page docs. And underneath, I suppose we'll start our to-do list. So here we're going to say the first thing is to to the quick start page. Acquire review data similar to coffee shop reviews. Okay. We're going to leave it there. That's it for this session. We're going to have 2 minutes break. We'll be back. I'm going to leave you with some nice music, and then maybe 3 minutes if I'm feeling generous, and then have a breather, and then we can come back and continue learning about this and doing our We'll just do those three. I think we'll finish the quick start page, acquire review data, and then apply 3 lines of sentiment analysis. Okay, see you soon. Welcome back. So let's get started on this next bit. So after tokenizing the words, which are multiple methods, I guess, and rules to do that, then you can turn them into numbers so that we can build a tensor out of them. And a tensor is essentially like a matrix of numbers with n dimensions. It could be a tensor of rank 1, 2, 3, 4. Each of those ranks are a different dimension now. So essentially it's just a grid of certain dimensions that contains numbers. The numbers are just data about the words. So basically we're, in a sense, vectorizing them or tensorizing them. I don't know what the exact word is, but yeah, we're just making them numbers. All the words into numbers. Numbers can be fed to the model, because a model, I guess, the language the model wants to use is maths and numbers, I suppose, because a word doesn't mean anything to a model. Two words are literally mean the same thing to a model, and one of a good example is having like a word with punctuation and the same word without punctuation, like hello and just hello. Hello with an exclamation mark. They would be like they would be false, like falsely equivalent, and in other words, the model computer doesn't recognize that these two are essentially the same thing without just one is with a exclamation mark, and that's bad for NLP because we're trying to understand. We're just trying to understand that words, even if they just have a punctuation, could be the same. We're trying to understand the understanding of what we're trying to teach the model, the understanding of two words. And so it's not very good if our model doesn't recognize that two words are the same, but one just has punctuation. So it's easier to do this if the words are numbers, and then the model can see that, oh, actually they're very, very much the same. And also it's much easier if we remove the punctuation. So removing the punctuation comes from the cleaning, tokenizing part. And so essentially what we would do is split the sentences into words, blocks, and they would also do this only if the words doesn't have punctuation. If the word has punctuation, the punctuation is removed or cleaned away, extracted and removed and binned, and then we're just left with the words, and we split those words up into blocks in a list, and then in that list is turned into numbers. So essentially that's how it usually happens. So to build a tensor out of them, tokens into numbers, feed them to the model. To do this, the tokenizer has a vocab, which is the part we download when we instantiate it with the from pre-trained method, since we need to use the same vocab as when the model was pre-trained. To apply these steps on a given text, we can just feed it to our tokenizer. Inputs equals tokenizer. We are very happy to show you the transforms library. This returns a dictionary string to list of ints. It contains the IDs of the tokens, as mentioned before, but also additional arguments that will be useful to the model. Here, for instance, we also have an attention mask that the model will use to have a better understanding of the sequence. The attention mask is an optional argument used when batching sequences together. This argument indicates to the model which tokens should be attended to and which should not. For example, consider these two sequences. The encoded versions have different lengths. So we can't put them together in the same tensor as is. The first sequence needs to be padded up to the length of the second, or the second truncated down to the length of the first. But we can pass the sequences in a list tokenizer and ask it to pad for us. So we can see that zeros have been added to the right of the first sequence to make it the same length with the second. Then this is converted into a tensor in PyTorch or TensorFlow, and the attention mask, as we heard before, is an optional argument used when batching it. So it indicates to the model which tokens should be attended to and which should not. So the attention mask down here is a binary tensor indicating the position of the padded indices so that the model does not attend to them. So for this BERT tokenizer, 1 indicates a value that should be attended to, while 0 indicates a padded value. And this attention mask is the dictionary returned by the tokenizer under the key attention mask. Oh, that's really cool. That's really cool. It's essentially like a little guide map for the model to know which values are not just padded zeros, and yeah, like complementary tensor next to the data tensor that says, oh, you know, the third column on my fourth finger contains a bunch of zeros, just ignore that. The rest of it is data though. Cool. Very cool. Back to the great payments. Attention mask. Binary 0, 1, 2, which segment. Very nice. So you can pass a list of sentences directly to your tokenizer. If your goal is to send them through your model as a batch, you probably want to pad them all to the same length. Truncate them to the maximum length the model can accept and get tensors back. You can specify all that to the tokenizer. PT batch equals tokenizer. We are very happy to show you the transformers library, and we hope you don't hate it. Padding true, truncation true, return tensors. The padding is automatically applied on the side expected by the model, in this case on the right, with the padding token the model was pre-trained with. The attention mask is also adapted to take the padding into account. So, in case you are wondering, or those of you who are new, the numbers here each represent a word. We are very happy to show you the emoji transformers library. Almost. Something, something, something. We hope you don't hate it. Something, 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 something. Okay, so there's also a full stop there. I'm not sure entirely. but because this has less words, yeah, that's right. It contains the IDs of the tokens. The input IDs are often only required parameters in that. They are token indices, numerical representations of tokens, building the sequence that will be used as input. See, there's more than 12 words. There's more than 12 numbers, but there's only 12 words here, or 12 what they call subwords, words or subwords. VRAM wasn't in the model vocabulary, so it's been split as V, R, A, and M. And to indicate those tokens are not separate words, there's a double hash prefix added to RAM here, and R and T and X as well. These numbers are the... Okay, so the tokenizer returns a dictionary with all the arguments necessary for its corresponding model. The token indices are under the key input IDs. Okay, so note that the tokenizer automatically adds special tokens if the associated model relies on them, which are special IDs the model sometimes uses. So it automatically adds. So even though there are just 12 words or subwords here, 2, 3, 4, 5, 6, 7, 8, 9, 4, 8, 12, 13, 14. So there's like two extra. There's two extra numbers, and two of these numbers are special IDs that the model sometimes adds because it uses sometimes. Okay, so if we decode the sequence, we've been given CLS and SEP. Okay. As well. And potentially those are the two, like here, you see 101 and 102 at the end. CLS and SEP. They're not included in the original sequence, but BERT model has added them because it needs CLS and SEP. It's expecting that as an input. So the tokenizer has associated with BERT model here that we're using. It's the BERT tokenizer, yeah. See, each tokenizer is kind of specialized to the model that it's using, and BERT model, I guess, uses BERT tokenizer and needs to encode sequences adding these special characters. And we read about the attention mask. Okay, some models, okay, so token type IDs, here we are. Some models' purpose is to do sequence classification or question answering, and these require two different sequences to be joined in a single input IDs entry, which usually is performed with the help of special tokens such as the classifier, CLS, and separator, SEP tokens. For example, the BERT model builds its two sequences inputs as such. that's that for now. Back to here. Yeah, and you can see it here as well. 101 and 102 have been added at the ends of both of these sequences, either end. So the 101 represents the CLS, the classifier special token, and the 102 represents the separator special token. So the zeros at the end are just padding so that the two lengths are the same, because models tend to need homogeneity in shape. Well, other than that, we're good to keep going. So we can use the model. Using the model is fairly simple too, I'm sure. Once your input has been pre-processed, send it directly to the model. As we mentioned, it will contain all the relevant information the model needs. If using TensorFlow, you can pass the direct dictionary keys directly to tensors. For a PyTorch model, you need to unpack the dictionary by adding a double asterisk. Oh, so the double asterisk isn't something unique to this library. The double asterisk is something I've encountered before. Very interesting. Aaron Fay in Stack Overflow has explained that this question is a very popular duplicate target and is often used incorrectly. So this question can ask about multiple things. For defining function with variable arguments, this is the current page you want to be on. But for a question asking what it means in function calls, as in calling a function with an asterisk before a parameter, see in here. Then for a question asking how to unpack argument lists, see here, that's the one we want. Because we're using the double asterisk here to unpack the dictionary. So I think unpack might be the wrong vocabulary here, but apologies, I'm sure this is a typical question. My question is simple. In a function that expects a list of items, how can I pass a Python list item without getting an error? So the answer here is function that needs strings, unpack my list. So you can use the unpack args. So my list can be any iterable. Python will loop over the given object and use each element as a separate argument to the function. Wow. Wow, that is very cool, very cool. And so we needed to unpack the dictionary to give it to a PyTorch model. In transformers, all outputs are tuples, with only one element potentially. Here we get a tuple with just the final activations of the model. The model can return more than just the final activations. which is why the output is a tuple. Here we only ask for the final activations, so we get the tuple with one element. Note. All transformer models, PyTorch or TensorFlow, return the activations of the model before the final activation, like softmax, since this final activation function is often used with the loss. Let's apply the softmax activation to get predictions. Import torch.nn.functional as f. Padded tensor predictions equals f.softmax pt outputs 0 dimension equals -1. So we can see we get the numbers from before. If you have labels, you can provide them to the model. We'll return a tuple with the loss and the final activations. I just wanted to thank GGMAAQ7 for the follow yesterday and Ghoul Devil Ape for the follow 3 days ago. Thank you very much. We're coming up to a little session break here for a few minutes. I think I'm going to be going for lunch this time, so I'll pause the stream and I'll be back after lunch. Sounds about right. Sounds good. Okie dokie. But before we do that, so we can provide labels, PT labels. Okay. Alright, and we can look into the training tutorial for more on using models. And it looks like the models are standard Torch or Keras model objects, so easy to use. We can save a fine-tuned model and load, and we can access the code. Customize the model, all sorts of things. Very good. So before I go, let's pick up the installation page, and we can say that we finished the quick start page. And let's open up a project area. Coffee, and check the git status, okay, and in this area we will work. Leave this to the side for now. Food in a minute. And installation with pip. In a virtual environment, if you're unfamiliar with Python, check out the user guide. Every virtual version of Python you're going to use and activate it. You want to use transformer, you install it with pip. Install with pip. Okay, first install both pip install transformers. So cd, okay, so activate learn element. let's check our environments. Conda info ems and source data. Okay. We are in our learn environment here, and we are going to pip install transformers. I had to. Okay, let's leave that to install, and when we get back after our food break, you will be using it. Happy times. See you soon. Hello, welcome back. So we are just looking into the transformer library for sentiment review analysis, and I've been providing a quick rundown of the library, an overview of the library, what it's capable of and how we can use it, and the claim that the library can run a sentiment review analysis in 3 lines of code seems to be true. So we're going to perform a sentiment review analysis using the transformer library in 3 lines of code now. So we've just gone ahead and installed the library with pip in a virtual environment. I'll open Jupyter Lab. And separate the 2 screens. Using the learn environment that we were installing it to, we can check that Transformers is properly installed by running. I suppose we run the source upgrade environment. We activate Python, C, transformers, okay, and call pipeline and so on and so on and so on, and then I hate you. Seems like there was a little error, and now it's downloading files onto my machine. The q.64101.dll error. q.64101.dll not found. And once it finished downloading that, we produced a label, negative score 0.9. So going back to my previous claim that 0.1 was highly negative, that's incorrect. The strength of the positive or negative score is from 0 to 1. The label itself is what makes it positive or negative, and the score 0 to 1 is how strongly that represents the label. So we know that it works in our learn environment. And so now we can go ahead and have a quick look at the philosophy. We can look at that later. Summary of tasks, summary of models, pre-processing, fine-tuning, multilingual. Alright, so let's go ahead and grab some data of the internet. Review data. Review data. Coffee has some 104 reviews here. So we're going to take this sentence and apply what we've been told we can use. So, from transformers, import pipeline. That seems to be okay. Or is it? Yeah, seems fine. And then second line of code. NLP sentiment NLP equals pipeline sentiment analysis. The result equals NLP we will also need to print the f string label result label I need to invert that square bracket here and also score round result to the square. 4 decimal places. All right. So let's check what our result is. What's the type of our result? Oh, okay, it's a list. I thought it returned a... Oh, it does return a dictionary. Okay. My bad. I've missed an indexing character here, so we need the 0. There we are. Now this should work. There we are. If we change the review to something else. Here we are, the very different review. The label is negative with a score of 0.998. So that's all for today. I'm applying for an API so that I can get access to all of the Google review data for Element Coffee, and we will be applying sentiment analysis and such things, visualizing how that looks for them and passing that data back to them. So stay tuned for next week's work, where we'll be doing more sentiment analysis for their reviews, and having a look at different ways to visualize the information that we retrieve. So thank you very much, and as you can see from 3 lines of code we get access to a complete working model of a sentiment analysis review. Thank you for tuning in. I've been Al. I've been very happy to host this today, and it's been back after a little while of downtime. So enjoy the following streams, and hope you all have a fantastic weekend. See you on the next week. Bye for now.